Hello, everyone. My name is Will, and my goal with this podcast is to talk to interesting people from my life about engineering, technology, and their experiences. My guest today is Brandon Wilson. Brandon is a propulsion engineer at Sierra Space, and he has extensive experience working on F-15 fighter jets from his time in the Air Force. Brandon was a huge help when I was first testing and building my jet suit, and I don't know if I would be where I am today without him graciously letting me use his backyard as a test space. In this conversation, we talk about his time in the Air Force, what college was like for him, and what he does now at Sierra Space. It was a lot of fun catching up with Brandon, and I hope you guys enjoy this conversation. Thanks for listening. Okay, yeah, basically, so I wanted to have this conversation with you for a couple different reasons, but basically, I realized that when we first met, it was back doing Space Race together, and then I
Mhm.
didn't actually know that much about you up until I started doing jet suit stuff and wanting to test jet engines, and then Mary Claire was kind of suggesting I talk to you about it, and then before we get into your background and everything, one of the things I wanted to ask you though was like, I don't know if you remember when I first reached out to you about testing jet engines basically in your backyard, but I just wanted to see what your initial thoughts to that was because we didn't really know each other that well. And it wasn't until afterwards where I learned a lot more about your background. But just curious what your thoughts were when I first reached out to you there.
Yeah, I mean, it was an odd request, but a cool one. And I've been playing with rocket motors and stuff for several years and blowing stuff up in my backyard or my parents' backyard, and so it wasn't like super like a super weird request. So it's like, oh, it seemed like a cool idea. I was like, yeah, bring it over. And I had some experience with like radio control, like airplanes and stuff like that. So I figured I might be able to help with some of the stuff, or worst case, I'd kind of just sit there and let you do your thing and hang out, have a couple of beers, and have fun with it.
Yeah, it ended up being a pretty fun time.
Yeah.
And it actually ended up being, over like a year and a half of me coming over and doing some crazy stuff in your backyard. But
Mm.
if you want to go into a bit of your background, basically, how did you, if you just want to summarize it quick as to kind of like how you got to where you are today, because there's a lot of places I want to go in terms of your work at Sierra Space and doing stuff at Madison with the rocket teams. But if you want to just give a quick overview of kind of out of high school, what did you do, and then how did you kind of end up where you are today?
Yeah. So, uh, out of high school, I joined the Air Force when I basically, actually, I think on my 18th birthday. So in high school, I was always interested in space and aircraft and stuff like that, but I wasn't a good student. Basically, a juvenile delinquent at the time, and got pretty awful grades. So it was never really, I was never really planning on going to college. The Air Force seemed like the next best for me because I could work on aircraft and didn't need a degree. So I did that for 8 years, and then after about 5 or 6 years in, I had gotten to a point in my job where the military is kind of, you know, just do what you're told. Don't use your brain a whole lot. So I'd gotten to the point where like I'd learned my job and I'd become proficient at it, and I wasn't really able to, I guess, uh, use my brain the way that I wanted to. Like, there's troubleshooting and mechanical things with working on fighter jets that keep it somewhat interesting, but it kind of becomes um, mundane after a while. And so I'd gotten some exposure working with some of the engineers at Boeing, and I thought that they had a pretty awesome job. Basically, they got to do all the fun work and didn't have to do any of the grunt work. I'm out on the flight line at midnight, 2 a.m., getting covered in jet fuel and hydraulic fluid, and they're all comfortable in their beds by that time. So I kind of decided that I was going to make a career change, and then on my second deployment, I was actually taking online courses just so I could like get accepted into a college. So in high school, I think I maybe made it to like geometry. So I was lacking in the math skills. So basically, I was just taking online courses for, um, math, all the calculus classes, chemistry, physics, and stuff like that, all kind of the core classes to allow me to even get accepted into a program. Um, so I finished that up over about a year and a half, 2 years. Finished off my second enlistment, and then moved back to Wisconsin without actually having been accepted to a program yet, which was pretty scary at the time. It was a major career change and kind of just hoping it went well. But I did end up getting accepted to UW Madison. Obviously, that's where we met. Um, and then yeah, just went through engineering school, which was a fun 4 years, as you know yourself.
It's so
So
hard, dude. It's so hard.
yeah, so hard. Uh, but yeah, so UW at the time, like we had like some small rocket programs there, but there weren't a lot of students that were involved, and UW also didn't have an aerospace engineering degree. So I kind of knew that I wanted to work on rockets, so I decided to kind of just start my own rocket group, and kind of just took over things. So we started off with what's called the Midwest Rocket Launch, which is a pretty cool program for undergrad students. But basically, every year they have different criteria for a competition, and all these colleges from the Midwest get together in like May or June and launch, solid fuel rockets. And they usually have, like for example, one year we did air brakes. So you had to launch a rocket up to a certain altitude and then recover that, put in a rocket motor that was like twice the impulse, but then you had to have an air brake system actually actively, you know, brake the rocket so that you'd reach the same altitude on the second launch as you did on the first. So they had cool things like that. Another year we did roll control, so actually, gimbaling the rocket and using fins to basically control the roll of the rocket on the way up.
Okay, interesting.
Um,
So you're using fins, not gimbal thrust.
yeah, no, yeah, solid motors. It's pretty difficult to do gimbal thrust because the burn duration is so short. It's usually around 2 seconds. So
Oh
basically,
yeah,
it's
that's
just
true. Yeah.
yeah, it yeets it up, and then after that, it's just coasting. Um, so then after the I think probably my junior, maybe senior year. That's when I think we met, and that's with the Wisconsin space race. So that trying to think, it was myself and Max Goldberg at the time
Yeah.
that came across the competition, and just prior to that, I was also working on a side project with a guy that was interning at SpaceX. We wanted to build a liquid biprop rocket engine on campus, and we never got that off the ground just because we didn't get funding for it. So that
Safety
died pretty
concerns.
quickly. Yeah, well, yeah, and safety concerns too. That's always a pain. Um, but then, yeah, I met Max, and he was brilliant at raising money, and so we kind of came up with a preliminary design and then just started reaching out for basically sponsorship money, if you
Hmm.
call it that, donations, and raised I think it was like $100,000.
Oh
And we
wow.
had gotten to the point where like our design was pretty good. Like I would call it somewhere between a preliminary design and a critical design. We had all of our test plans written, all that stuff, and we were kind of ready to go. But then we kind of all graduated. So we we didn't want to um, we didn't know who was going to take over the program, so we ended up basically giving the money back, unfortunately, and the
Mm.
program kind of died from there. There were still some students on the team after we left, and they were working on like hybrids and other rocket programs, but the space race program kind of died. Let's see. So that was space race stuff. I guess in parallel, I was interning at the time it was Sierra Nevada Corporation or Orbitech. So One of the reasons that I actually decided to go to UW Madison is I knew that there was a rocket propulsion company right down the road. So I tried to get my foot in the door as quickly as possible there. And I was able to get a part-time job, I think either my sophomore or junior year there. And I was more of a technician than an engineer for like the first year or so. So I was hired to help build up a test stand for the Dream Chaser thrusters. So that was more of, you know, a lot of plumbing and wiring and stuff like that. Um, I went on to, after we finished that, I went on to start to write the data acquisition system for the test cell. So that was, the basically the thing that actually controls all the valves and records all of your data and stuff like that. Writing the code for that. Um, After I graduated, I got hired full time, um, and started working on kind of a slew of different programs, some hybrid work, and some proposal work for various things for NASA, and then the program that I work on now, which is an upper stage 35,000 pound rocket engine.
Oh, wow. Yeah, so there's a lot there, and I want to go kind of step by step through a lot of that. But one of the things that kind of stood out to me when you were talking initially about being a bad student, like I totally understand. Would you have thought when you were younger that this is what you would have ended up doing? Because I imagine like it's hard when when you're in like high school, you think it kind of dictates everything that you do. And so you're looking at it going like, oh, like I'm a terrible student. Like I'm probably not cut out for this academic route, let's say. Um,
Mhm.
but could you have imagined, like, did you have an interest in rockets and airplanes? And did you understand that like in order to pursue that route, you were gonna have to figure out how to get good grades, or did you not really think about it? And it was just like,
Yeah, no, I didn't think about it at the time at all. I mean, I knew I liked airplanes, but like I set the bar pretty low. I just kind of assumed I was going to be, well, I shouldn't say low. It's not low to be an airplane mechanic, but I always kind of assumed I was going to stay in the kind of technician type role. Never considered engineering until I started working with them more while I was in the Air Force.
you realize you start to know more than they do.
Yeah, I mean, I went, yeah, I mean, you're like, what, who designed this thing? And then you get on the other side of that and you realize like we've had conversations in like meetings like, oh man, the technicians are gonna hate us for this, but it's like it's the best, it's the only way that we can do this. Like, I'm sorry, sometimes things aren't gonna be maintenance friendly and it's a pain. We
Yeah,
do
that it's
uh,
so sorry, I don't mean to cut you off, but you were just
no.
as I've built more things, I've that's something that nobody really teaches you at first, which is like thinking about who's going to be using this and how they're going to be interacting with it. And
Mhm.
so, I mean, I remember like a prime example was working on my like jet suit stuff, where it's like in my head, I would like design something, and then it wasn't until I was building it where I realized like, oh, I can't fit my hand in there to actually turn that bolt, or if I do,
Right.
like it's going to take me 10 minutes to get this off, and that's fine maybe
Mhm.
on the bench, but if I'm out testing, like that's going to be a pain in the ass.
Mhm.
um and so it's interesting that you were on the other side of that, seeing some of those seeing some of those design decisions and being like, who in the hell came up with this? That's really
Right.
funny. So basically what was the Air Force was basically the best option for you to get basically to working on planes the fastest? Was that kind of the logic there?
Yeah, other than that, I mean, you could go to like a trade school for like 2 years.
Mm.
And I also kind of part of me wanted to eventually be a pilot. So the Air Force, recruiters lie to you and basically they're like, oh yeah, if you do this for 4 years or whatever, you do some training, we'll pay, all of your tuition will be paid for. You'll be able to go to college for free. Once you get your degree, you can come back as an officer, get into the um, pilot training school or whatever. And what they don't tell you is that you're going to be working, 70, 80 hours a week. So you don't have time to go to college. And there's no way you're going to graduate in 4 years if you're taking, one class at a time.
You were
So
doing 80-hour weeks?
it was pretty brutal. Yeah. So um, crew chiefs or flight line technicians, whatever you want to call them. Basically, your schedule is dictated by the flying schedule. So there, and it rotates too. So like if the jets are taking off at say noon one day, I always work the night shift. So after the jets come down, you do all the inspections and repairs and get them ready for the next day. So I might come in at like 8 p.m. one day, but then have to come in at like 2 a.m. like the next day if the schedule shifted. And the other thing is you don't leave until the job is done. Like there's nobody to turn you over because we're so short manned. So basically, you just did your work and you went home when you were done. They did have like a drop dead time. Like you were only allowed to work 12 hours on the flight line, but you're still technically allowed to work up to 16 hours with like all the paperwork and turning in your tools and everything.
Dude, that
So
sucks.
yeah, it was it was
So
a really bad.
how did if you were working, like, was there ever a risk that if you're burned out, like you make mistakes and you're talking about like full aircraft here? So it's like,
Mhm,
did you did that occur sometimes of like stupid mistakes because people were just burned out like at the end of their shift? Like you see this in all sorts of fields, medical and things. It's like with nurses or whatever. But
mhm.
did you see it? Did you see mistakes like that were pretty bad?
Yeah, I mean, there were a couple of people that fell asleep driving, either a tow vehicle or a truck, crashed into a, $50 million jet. Some people have died. Like while I was deployed, a woman there had she was loading a bomb on the bottom of a jet, and I don't know exactly what she did, but it ended up dropping on her and killed her. So I mean, yeah, like
Jesus.
people get burnt out and mistakes happen. Obviously, usually it's not quite those are not often.
Extremes, but
Yeah, those are
yeah.
extremes, but yeah, I mean, even just forgetting to sign off something in the forms on an aircraft at the end of your shift. And then when the pilots get to it and they're like, hey, this jet is still grounded. And then people are like, well, what happened? And get called back in to sign off your jet.
Dang, that's pretty crazy. So, what was there a specific airplane that you worked a lot on, or were you kind of rotating through different sets, or what did that look like?
Yeah, I worked on F-15E Strike Eagles. Technically, I could have worked on or the third gen, basically F-15s, F-16s, F-117s before they retired. But there's a handful of aircraft that you're like qualified to work on and in a certain career field. But I stuck with F-15s the entire time I was in.
So, was that pretty cool? Like the first time you start actually getting your hands on a jet, was that I have to imagine, especially when you're a kid at that point. So you're like,
Mhm.
were you like, dude, this is awesome. I get to work on military jets. Or was it like, how did you feel about that at the time?
Mixed emotions, I guess. Yeah, I mean, like you even just like walking up to a jet, that and you get your name on the side of it and everything too, because they've got like a dedicated crew chief, kind of the owner mechanic of it. So that part of it's kind of cool and like you're always working right next to the runway and watching them take off and do flyovers and stuff like that. Pretty
So I,
cool.
I imagine it's pretty cool at first, and then at some point it normalizes, and then you're
Yeah.
like, this is hard and it sucks. And was that kind of your experience, or?
Yeah, and I wouldn't say I wouldn't say it sucked. Like it definitely gets normal to where like it's just you're literally there more than you're at home, so you just get used to it. And like the job definitely didn't suck. It was a good job. I had a lot of fun. You meet the coolest people because when you're working those kind of hours with the same people day in and day out, you develop like super good friendships. You travel the world with them all the time. I slept in a tent with the same dudes for like almost 2 years. So like you get really close with people. So there's that side of things where uh, it made it a a worthwhile and a fun job, but it's not something that I wanted to be a long-term career, even though I
So
got halfway to retirement.
yeah, yeah, right. So at what point then? So because right now you're basically fixing and working on airplanes. At what point did you kind of decide, was there like a time where you kind of decided like I want to start actually designing this stuff and coming up with new ideas. Um, as a kid, were you for me, like if I look back, I was always kind of, I don't want to say, I don't think of myself as highly creative, but I was always building or fixing things. Was that
Hmm.
something that you were like coming up with new stuff a lot, or did you kind of develop that as you got older? So then as you're in the Air Force, you're kind of like, oh, I want to start seeing if I can actually design this.
Um, yeah, I guess I would kind of be more, I'm kind of similar to you where I've definitely, done a lot of tinkering and a lot of like fixing things and a lot of like just, making things that weren't like well,
Yeah,
properly
yeah.
designed and stuff. Not super creative. And I think I'm kind of still that way. So even as an engineer now, I'm not really a design engineer. I do more with data and analysis and kind of troubleshooting and kind of analytical type stuff. So I think
Mm.
I've kind of stuck with that. The the design, if you call it design, I guess it's more architecture. The other thing that I would consider myself good at is like coming up with like a I guess, yeah, like a system architecture. Like, so if I'm, for like a rocket engine design, kind of coming up with the initial parameters that you need for everything, like this much thrust, this type of propellant for this type of mission. And then from that, you can come up with like, size, the general geometry of specific components and stuff like that. But when it comes to like actually like designing and kind of the creative part of things, that's where I'm still not very good at. And I'm
I mean,
okay
lean
with
into your strengths, right?
that.
If
Yeah.
you're good on the analytical side, we need plenty of those people. Um, so I guess then going maybe we'll come back to the military side of things, but going from that then and deciding you want to go to college and you want to, you decided you wanted to get a degree in engineering effectively. Um, what was that experience like now that you were, how old were you when you went, let's say like when you got into Madison and actually started attending classes there? About how old were you at that point?
26.
So, okay, well, that's I'm 26 right now. So
Mm.
I'm trying to imagine what did that feel weird to you being in classes with kids that were, I guess maybe like 20? So, and
Yeah.
did you feel like you didn't quite fit in there, or what was that experience like? Because I feel like
Yeah.
you've had a lot more life experience by that point, especially going through the military in that way. And I'm curious what going to school after that is like.
Yeah. The first year was definitely somewhat like that. As a freshman, you've got all of your kind of core engineering classes, which are, like almost half the people wash out of anyway. So it's difficult to build friendships when there's 200 people in the classroom and you're like this old tattooed guy like sitting in a corner and people, so it was definitely a little difficult for me then. And that and being, out of school for so long, it made it kind of rough just because everybody, it's all everybody's already building on what they've just learned in high school. And I'd been out of high school for 8 years at that point.
You got to develop
Uh,
those habits again of like learning. It's an entirely different environment, so it's a lot easier if you've just come from that to play that game again.
yeah. But after like, so in my sophomore year, I met Richard, who he was in some of the Rocket teams as well, and he was a little bit older. I think he was, like 22 or something like that. But he was like partner in my one of my computer science classes. And so I was at least able to build a friendship with him, and then we could kind of lean on each other because you do need that in college. Like I'm sure the people that were in college during COVID definitely had a hard time because it's tough to get through tough programs by yourself. You need people to lean on and people lean
It
on you. So
it took me a long time to learn that because I was somebody who always I enjoyed studying by myself and I enjoyed kind of spending time by myself. But the problem I realized was that especially when classes got harder at some point, like you needed people, yeah, you needed a group to be with because you had to be
mm,
able to think and bounce ideas off of each other and have somebody explain to you why they understood it. Like I totally get it. And it took me a while to figure that out too.
mhm. So yeah, I mean, um, yeah, like I said, first year was. tough, but then second year it got a little bit easier, and then after that it just got easier and easier. By my senior year, I had basically a good group of friends, and we all uh, studied hard, worked hard. There were nights that we were at the library until like midnight, and then we'd go to the bar until like 2, and then be up at 8 a.m. doing it again. So
Yeah, yeah. That's do you think that being in the Air Force helped you with your work ethic? Because one thing that when I got to school, I didn't know how to work for long hours and I didn't know how to
mhm.
work like rigorously. And that was something that was like a skill I had to develop. Do you feel like you learned that? And then when you came to school, like for me, it was really hard to learn that. I'm like, dude, this is hard. And
Mhm.
I'm spending hours and hours working and having to be focused. But my question is like, if you're coming off of, you're used to 80-hour weeks with your working on airplanes, did you find that aspect like easy to manage, or was it still pretty difficult?
I was surprised at how difficult it was because I had that same thought. I was like, I'd just come back from a deployment where I was working literally 16 hours a day, 6 days a week, and living out of a tent. Like, and at the same time, I was taking, I think, 2 college courses. So I was like,
Jesus.
oh, now all I have to do is just go to school full time. I don't even have a full-time job. Life will be so easy. And then I found out very quickly that it was a lot harder than I thought it was going to be. But I do think having that experience uh, definitely helped because without that, I think if I was just, 26 years old going back to college without having that type of work ethic, I maybe may not have made it and done something else. I don't know. But
Yeah, it's really interesting. I mean, I'm trying to think back to my freshman year and like my grades were not good. And I learned
mhm,
very quickly, it was like, I'm gonna have to step this up if I'm gonna do well in this because I don't have at the time I didn't have the grit that it would take to kind of push through some of those difficult classes. Now, granted, they're weed out classes, and if you can make it through
mhm.
that, then it gets a little bit easier in some sense. But yeah, that's really interesting. So you end up well, there's a couple places here. You end up going to Sierra Nevada then for an internship. What was there a pivot because they do, rockets and space? Was that kind of an interest that coincided with airplanes, or did you at some point start to diverge and go, I want to do rockets and space. I care less about airplanes, or did it not really matter either way?
Yeah, I think when did that? I think just prior to me getting out of the Air Force, I knew I wanted to do aerospace engineering. I wasn't sure exactly what I wanted to like become an expert in.
Hmm.
Um, and I think at some point in college, maybe like my second year, I was like, okay, yeah, I'm not going to do um, jets, or I was thinking of doing fighter jets, basically get into like a Boeing or Lockheed or something like that. But basically just doing the rocket programs. And at the same time, I got really interested in like just cosmology, watching like PBS Space Time and like all these,
Hmm.
documentaries and stuff like that. So I got super interested in just space and stuff, and rockets and well, satellites and stuff in general. But then I was kind of still uncertain. So I knew basically at that time I wanted to do space stuff. I didn't know, do I want to do rocket propulsion, or another thing that I was really interested in was like flight dynamics, especially for like hypersonics. That was really interesting to me. Satellite dynamics, orbital mechanics, all of those are kind of things that I was interested in at the time. Um, I think my internship at Sierra Nevada definitely solidified the propulsion aspect of it.
Hmm.
Um, and and ultimately, I think it was either my junior or senior year where I took a um, the rocket propulsion course, and I was like, okay, yeah, I'm doing this as an intern at work. I'm learning this. I'm happen to be pretty decent at it. It comes to me fairly naturally, so kind of just decided to stick with it.
Nice. Yeah, that's pretty interesting. So you found that I don't want to say had a knack for it, but like everything kind of came together in this. You found the interest for it, and then you also found that you were motivated to keep working and studying it.
Hmm. Yeah.
Interesting. So when did you, if I remember correctly, you were the president for one of like the rocket, what is it? The aeronautics, sorry, American Institute of Aeronautics and Astronautics. Um,
Yeah.
how did you get into that, and how did you end up as the president of that? And like, how was, because I think you did that for what, like a year or two?
Yeah, I did that for I was the vice president for a year, then president, and that was of like the student chapter at UW, and then I was the president of the state chapter for um, for professionals for 6 months, and then I actually ended up stepping down because I was too busy with work.
Mm.
Um,
What was that
but
experience like?
so the it's a professional organization, so um, um, from the student chapter side of things, I think is really beneficial because it gave us access to things like grants and kind of professionals who could have like speakers come and kind of um, talk about their area of expertise to kind of hone in on what do I as a student want to be an expert in. So it was super useful for that. As president of that, I mean, basically, um, it kind of just fell on me. I was already the president of the rocket team, and the former president was leaving, and he worked on the UW UW robotics team. But he graduated and kind of just handed it down to me. And basically, I mean, I was just in charge of setting up presentations for the students and kind of just being involved and trying to get us grant money for these rocket projects and stuff like that. Um, on the professional side of things, I didn't do a ton on that just because I was so
Mm.
busy with work at the time. So
Yeah.
I won't speak too much on that other than you know a lot of that was kind of uh, the opposite. So the students reach out to the professional org and they help the students, and we kind of reached out to the students quite a bit to kind of like see like what do you need or help them build a rocket test stand on campus. How do you navigate all the legal and safety aspects of things like that?
That honestly sounds like a mess. Like I couldn't imagine the hoops you have to jump through to try and do that, especially when you start talking about, well, like you said, rockets. Like I feel like they started. I have to imagine administration gets really squirrely about that kind of stuff. But
Yeah, they shouldn't though. I mean, there's like I mean, rocket testing, rocket engines, rocket vehicles, obviously very, very high risk, but the high risk doesn't mean that's unsafe as long as you are far away from it and
mm,
you're not loading high pressure propellants into it while you're standing next to it. You automate things and stuff like that. Like whereas your jet suit where you're strapped to that's I wouldn't necessarily say that's super high risk because those are pretty well engineered, but you
higher
have to be
risk for
close
sure. Yeah.
for your for injury, yeah. But high risk in terms of like dollars and damaging equipment. I mean, I don't think it should be that difficult to set programs up like that on campus because students do need to, if you want to get into this business, you need to kind of get your hands dirty and learn how to do it as a student because there are plenty of colleges around the country that have programs that are doing it right now and they're getting that hands-on experience. So the universities that aren't doing that are kind of missing out on it, which was kind of another reason why we wanted the Wisconsin space race to succeed. It was basically a means for us to fund basically research and testing on campus, basically build that infrastructure so we could do that project, but then students in the future could have that there
Yeah, that's really
put into use.
interesting. I imagine if you're an aerospace engineer, especially if you're trying to get into rockets, like there isn't really a way that you can do that on your own. You can learn a lot, but in terms of
Mhm.
like you said, kind of actually getting hands on, that seems like it would be pretty rough. And like you said, if other schools are starting to set up programs like that, that puts those students ahead by like a huge margin, I have to imagine.
Mhm.
Um, yeah, that's interesting. I guess I haven't thought about that before. I haven't dealt much with the rocket side of things. But yeah, that's pretty rough. If especially I mean, again, I remember because we did. So I was in like I did like the initial space race stuff, so I had like some of the information, but I think like some of the other teams seemed way more put together. And at the time, I was like really surprised because I thought everyone was like starting from absolute scratch, but
Mhm.
it seemed like a lot of those places had a little bit more kind of put together initially.
Yeah, I mean, you look at like Purdue where they have Zucro, so like I think one of the largest, if not the largest, student-led ish research propulsion test facilities, at least in the country. And yeah, I mean, all basically most of their students are pretty much guaranteed a job at like a good, aerospace or rocket company or whatnot. And I mean, just think about, your jet suit, how much you learn with actually applying what you learned in the classroom and actually, building the thing and testing it and figuring out like all the design flaws that you had and stuff like that. Which I mean wasn't a cheap thing for you to, shell out yourself either, but like rocket components where you have to use fancy nickel alloys like Inconel or copper's not
The
cheap.
super
And
high temp stuff, yeah.
yeah, like you can't build a rocket engine for, I mean, you need, if you're really good, you can maybe do something for like 20 to $30,000. And that's like it's still
On
gonna
the
be kind of cheap.
Yeah, it's on the cheap end, yeah.
And the other kind of thing that sucks about it is, well, I don't know if sucks is the right word, but the kind of the cheaper you go, the less safe it is too. So like I've seen a lot of videos on YouTube of people making these rocket motors, and they're like these pressure fed things that are basically like little pipe bombs, and they're standing like 50 feet away from it. It's like
You're
that's how
talking
you
about
get
are you talking
yourself
about
killed.
are you talking about liquid? Like liquid?
Hmm.
Jesus.
Yeah,
Yeah,
liquid.
that's
I saw a video. I saw a video of a dude that made a hybrid motor, and his like 4-year-old kid was standing like 10 feet away from him when he like hit a button to like fire the thing. I was like, that is so dumb.
man, that's gotta be, I mean, I'm all for like trying things yourself and taking risks, but like there's a line where it's like, okay, this is stupid dangerous.
Hmm.
Well, I know I'm trying to think back because you were doing some rocket motors in your backyard for a while. It was solid though, right? How was
Yeah.
I got two questions there. One, how like have you been working on that at all recently? And two, like how is that? You're building your own rockets in what your garage effectively.
Mhm. Yeah, so um I still kind of work on them. I've actually got all the propellants and a bunch of stuff in my closet right there next to me right now.
Has
And I've got one
has the
ready to
ATF
go.
called you up anytime recently?
No, no. So I've solid solid motors use ammonium perchlorate and HTPB, which is kind of like an almost like a rubbery epoxy, and uh, basically aluminum particles and a couple other additives. But it's all stuff that you can buy, and you're actually allowed to buy. I forget what the quantity is, but it's somewhere. I think it's more than 10 pounds. Maybe it's like 50 pounds, but you like anybody can buy like 10, 50 pounds of this stuff because they use it in like fireworks and stuff like that. And there's nothing illegal about um, making them. You're supposed to technically have a high powered rocket level 2 certificate, which I have. But um, I mean, it's fairly safe as long as you kind of do the research and make sure that you mix them in a well ventilated area and you're not getting like these tiny little particles floating around that can ignite. And when you do fire the thing off, I've got basically a stack of tires in my backyard. And I kind of put a little barricade there, and I have a remote that's wireless, and I'm standing 200 feet away at least. So it's
Yeah.
fairly safe.
Well, I guess it doesn't really become super dangerous until you contain it, right? Because then it pressurizes, whereas before, if it's in the open, it'll burn, but it's not a violent explosion, right?
Yeah, so solid rocket motor or solid rocket fuel is pressure. The burn rate is pressure dependent, pressure and area. So basically, it's yeah, if you like undersize your nozzle throat on it, or if you don't. pack the propellant in or pull vacuum on it, you've got like little air bubbles in there, which you end up getting as kind of a chemical reaction that kind of quickly goes out of hand. It starts burning faster, and then it builds more pressure, and then it starts burning faster because of that. It just runs away and blows up pretty
Mm,
much immediately.
interesting. So I guess taking this slightly different to a different place now, at because that's easy enough to do in your backyard. Have you what's the process like when you're now in a professional setting and you're now dealing with these much larger, much like the liquid rockets? Like that stuff gets really, really dangerous, doesn't it? And I guess, or maybe not. And I guess you're going to know a lot more about this than I do. I actually I don't know that much about rockets other than what I've learned on the internet. But what does like risk mitigation look like? And have you guys had like, have you had any serious failures with some of the stuff you've worked on before? And what's that process look like in terms of like what you learned from that?
Yeah, I mean, like like I said, it's definitely high risk. I wouldn't say it's unsafe. So
Hmm.
we're in like our control room is, like half a mile away from where the actual test cell is, and we've got, giant barricades all around kind of the control room. So the only hazard there would be like if you really blew something up and like a chunk of steel or something got kind of lobbed and busted through the ceiling. But
Yeah.
when you design a test facility or test cell, there are certain um, specs, standards, I guess, certain standards where you basically there are calculations that you can do to figure out like what the blast radius is of how much propellant you have on site and like kind of a worst case scenario.
Like
And
if
then,
this all goes up,
yeah, and actually you don't build it to that because that'd be a little too extreme, but it's like,
you want to know what that is though.
yeah, you want to know what that is, and actually, I've never done these calculations, so I'm no expert in it, but I know it's basically some percentage of that, and that's kind of like your keep out area. Um, so in terms of like safety, it's not really not really an issue unless you're like some rogue company or something like that. Like I saw a
Mm.
YouTube video of some startup company and they're standing like next to their launch vehicle, which it looked like it was using um, hypergols, so basically really toxic propellants, and like there's just like this red fumes of like death, and they're like running away from this rocket. Like that's just stupid
Jesus.
unsafe. But most companies, even startups, aren't that dumb about it. But for high risk of failures, yeah, failures definitely happen. I've had a couple. I don't know if I can say the specifics just because
Yeah, yeah, for sure. Understandable.
work may get upset about it, but like rocket engines are uh it's a lot of energy that you're containing,
Yeah.
and
You're
like
sitting on
timing.
I mean, if you're on a rocket, you're sitting on a bomb. Like,
Yeah, I mean, well, I wouldn't if it's so if your propellant goes up, it's probably gonna be a deflagration, not an explosion, so
yeah.
a subsonic pressure wave. But yeah, if you were to contain all that, a lot of energy. But yeah, I mean, like timing of, valves, like everything has to be really precise. And if it's not, you might burn up some hardware, just melt some stuff, which is never fun, but it's not the end of the world. Or you could have, a pretty good um, explosion or damage a facility or something like that. Um, and that stuff happens. I mean, it's going to happen. And the companies, the newer startup companies, you look at like SpaceX, the ones that are really progressing really quickly accept
Hmm.
accept the fact that they're going to have failures, and they plan for it, so they'll have a bunch of spares, and they'll spend less time and money kind of on the analysis and getting things right the first time, kind of the old NASA way. They kind of are just like, let's just kind of throw money at this because I mean you could do all the analysis you want, and it's the calculations involved and the simulations and stuff like that. There's errors baked into that. You're dealing with cryogenic and supercritical fluids, and there's just there's errors in all of your calculations, so nothing's ever going to be 100%. So sometimes it's faster to just take more risk, burn up more hardware, and move faster.
Yeah, it's interesting to see how the industry has changed in that way in the last pick a number, but let's say 10 or 20
Mhm.
years, right? Where it's like you look at a lot of the older legacy aerospace companies, Boeing, Northrop Grumman, like these kind of behemoths, right? And they have this, and even, I mean, even with NASA too, where it's like, it's kind of this strict, like you've got to get it right on the first try, and we're going to spend 5 years developing this smoke detector. And it's just interesting to see like some of these commercial spaces pop up where they iterate so quickly, and it's like when you think about it like rocket development, again, you look at SpaceX and it's like in the amount of time that they can go from nothing to having almost a fully functioning prototype is insane. Now, granted,
Mhm.
everyone's working really hard hours too, but like you said, that or what's the saying, right? It's like fail fast, fail early. And you
Yeah.
just learn so much more from that. And so if you accept that as the process, it's just an entirely different way of thinking about it. But it's true. Like you learn the most from that versus trying to go through like the analysis is important, but if you can
Mhm.
get stuck there for a very long
Yeah.
time. And I mean, that's what I did with my jet suit, where it was like I just started building stuff and I started to figure out immediately what worked and what didn't. And it's like, as long as you don't kill yourself in the process, like you just keep learning and keep iterating. And that's a um, far faster to kind of get to your solution space.
Mhm.
So,
Yeah, you kind of need both. And as you know, I'm at least lately I've been full-time analyst, so I should defend myself a little bit here. But analysis is important, but like you can be good at analysis too. Like, right, you don't you can know that like I'm creating a model, I'm simulating something, and I'm trying to get something out of this. It doesn't mean that I need to simulate every quark and like subatomic particle in my model. Like I'm modeling what I need to understand to prevent failures from happening. And you can do that quick if you're smart about it. So you definitely need both. You can't just throw parts at things and just trial and error. So I'll throw that tidbit out just so I don't, lose my job.
well, I agree with you. Yeah, yeah, there you go. Making yourself irrelevant. No, the analysis I think is important initially because it points you in the right direction, right? It gives you an idea of order of magnitude in terms of what to expect. But then the things that you're going to get stuck on are the small details where you're like,
Yeah.
oh, like there was no way we could have known that this was going to occur until we tested it. So like maybe the faster we do it. So yeah, I mean, I totally agree. The extreme on either end isn't good. You do need a good
Right.
mix of the both.
Yeah.
So that's pretty interesting to see. Going back to your time in the Air Force, then I'm just kind of curious there. Like, I remember you telling me a story one time, or you might have mentioned it in text that you saw like a jet engine shell out because a turkey vulture got sucked into it. Like,
Oh, yeah.
how many stories like that have you built up? Because you were in the Air Force for like 7 or 8 years. How many
Yeah.
was that a rare occurrence, or were there just constant times where you were like, what the heck is going on?
Yeah. Bird strikes are fairly common. I would say like, at least like one a month or something like that. But
Mm,
usually it's like, it hits a wing or like the nose of the jet or something like that,
yeah.
and breaks a panel or cracks something. It's not that big of a deal. It's not. Um, well, that and some actually do go down the intake, but they're small enough birds to where like maybe it like nicks a blade or something like that. But it's not a big deal. You inspect it, you kind of file it down, and it's good to go.
Do you have to
The
balance that? Because if you I mean, I guess maybe on the larger scale, maybe it's not as big of a deal. I know, like with the smaller engines I've been using, like if those things aren't balanced, man, it'll rip itself apart. So, like on the bigger engines, is that a big concern if you damage one of those blades, or is that not too big of a deal?
There's limits, so usually it's like so if you were to picture like a dime and then kind of cut that dime in half, that would be like the largest size of a nick. That would, well, not a nick, but after you actually blend the blade. So there's limits to allow for that.
Mm,
And some certain stages, like your first stage might allow some, engines might be different, but some stages might allow some damage, and then like further back and like the stages, they might not allow any damage. And then
Mm,
they also get overhauled every certain amount of hours too. So
yeah,
if it was repaired or whatever on the flight line, chances are it's going to get replaced when it goes to back shop for an overhaul.
gotcha. Did you ever see any I'm trying to think of I feel like I just saw a video recently of I think it was one of the F-35s that does vertical landing
Hmm.
and it was coming down for a vertical landing and I don't know if it was the flight controller or what the heck happened, but the thing suddenly like tipped over and then started
Yeah,
scraping its I don't know if you saw that video or not, but like did you ever
yeah.
see anything like that occur when you were in the service or nothing that crazy?
Oh yeah, yeah. Let's see. I don't know. I think probably one of my I've got a few, but like one of my more fun stories was so I was deployed, and so like our spots were basically right on the runway. So like at a home base, you usually a bit further away, so you don't actually like watch the jets take off and land. Like you can see them from a distance. But at this particular location, like the jets were like 50 feet next to me. Like the runway was right there, and I had my jet that I had just launched out. Heard that it was coming in for an in-flight emergency for a hydraulic failure. And so when you have a hydraulic failure, there's backups and stuff, obviously. But one thing that they do to make sure that they're actually safe is there's like an emergency landing gear thing that just uses like pneumatics to open up the doors, drop the landing gear. They also have a tail hook, kind of like on like a carrier to
Yeah, to
catch it.
catch the cables. Yeah.
Yeah, so they're not designed for carriers on like land fighter jets, or Air Force fighter jets, things that aren't on carriers, but they are there for emergencies. So if you lose the brakes, so if you have a hydraulic failure, brakes are hydraulically driven, they're going to use the tail hook to stop. But then they also have emergency brakes, which are pneumatically actuated. So lots of redundancy baked in, but trying to be as safe as possible. So I'm just basically sitting there like, oh yeah, hydraulic failure. Yeah, that thing was leaking. Time to fix that, I guess, because these things just like like you kind of know your jet after a while to where it's like, yeah, it's good enough for this flight, but if it comes back for that, you're like, yeah, I knew that was gonna fail soon.
You might
But
have
anyways,
you might have specified this earlier. So were you only working on the same jet every single time?
no, so like you're in charge of us, like you're in charge of your jet, but like I worked on every jet, and I was when I the last couple of years I was seven level, so basically I had to sign off on all of the jets at the end of the day to kind of like you inspect them and sign off other people's work. So I
Oh,
worked on
a lot of
everything.
responsibility.
Yeah.
Okay,
Um,
sorry. So going back to hydraulic
yeah.
failures then.
Right. So really wasn't a big deal. Like I heard on the radio, I'm just kind of like sitting on my toolbox waiting for my jet to come back. I see it enter the pattern, and then I see it come down on the runway, and it um basically comes into land. The tail hook catches the barrier, and then it just rips off, and like along with like a chunk of like the back of the plane. I was like, oh,
Jeez.
what was that? And then all of a sudden the jet takes back off. I was like, what do you? No, don't do that! Like the ass end of the jet just got ripped off, and
I wonder if the
so
pilot thought he missed or
yeah,
like, oh,
that's what it
okay.
was. So
Oh,
she actually, but she thought she missed. Comes back around, and then at that point, like I don't know, maybe it was nerves or something. I don't know. But so she comes down, and with emergency brakes, you don't have ABS, but
hmm.
basically she just locked these brakes up, and then so immediately comes down, lands, locks the brakes up, tires explode, like they just blow up. It's sliding down the runway, like the brakes were ground, like the tires, which were like the big, like you know, 30 something
Those
inch
things are
tires.
huge. Yeah.
Yeah, and the rims that they were on, it was literally ground down to like a half moon, caught on fire, slides off the runway, like pilots like pop the canopy out and like jump and run. I'm just standing there at my toolbox, like, what is happening to my jet right now?
You're like, I can't fix that anymore.
Yeah. So it turns out that she had forgotten to So you have like a max landing weight, and um, since she had a hydraulic failure, and it was a pretty bad hydraulic failure, so she wanted to get on the ground as quickly as possible. She didn't dump enough fuel in time, so the jet was too
Mm.
heavy. So basically, that's what caused the tail hook to get ripped off, and then
Oh, so
ultimately,
it still had a lot of momentum coming in, and then
yeah.
oh, interesting. How do you dump fuel? You just hold pattern until you burn through it?
No, there's actually like vents. So basically you just flip a switch and it opens up some valves, and there's some on the outside of the wingtips. So sometimes when you see like a fighter jet and it looks like it's, like a wingtip vortice or something like that, it's actually them dumping fuel. I don't know if you saw um the Russians that kind of took down our drone a few weeks ago and said that they were spraying jet fuel on the drone or whatever. That's basically what they're doing. They're flying up over the drone and flipping their dump on there to dump fuel on it to try to
Oh,
basically get it to go
that's
run
interesting.
quickly.
I didn't know that they had that capability, but it makes sense,
Mhm.
I suppose, if you need to drain your tanks too.
Yeah.
Interesting. Yeah, that's I was at an air show that would have been maybe back in October, and I was watching, I think F-22s doing
Mhm.
flybys, and like they were close too. So like those things are big, they're loud, and but if I had to imagine that thing coming in and crashing in that way, I'd probably increase your heart rate a little bit.
Yeah, especially when you're like the last person that like signed off all the maintenance on it and like
Oh yeah,
you
you start to wonder like, was that me?
did I mess
Uh
anything
yeah,
up?
you're
Yeah.
running the checklist in your head like, oh
Yeah.
crap, I should have had one more cup of coffee last night.
Right. Yeah.
Dang, that's wild. We can wrap this up here. I guess I got one more question for you. If you have any advice, I suppose, for, you know, kids coming out of high school, they're maybe they're interested in engineering or technical, just kind of technical work. Do you have any advice for them? Is from the route that you went going into the military first and then doing school later, is any advice for how to because you ended up in a pretty cool job, doing rockets for Sierra Space and the Dream Chaser stuff. So any advice for students on how to kind of get to something similar if they want to?
Yeah, I mean, I personally wouldn't recommend my route. I think it was
Mm,
probably it was probably I mean, there's nothing, if you want to join the military or work on fighter jets or something because you want to do that, by all means. But I wouldn't use that as like a path to like get into aerospace engineering per se. I think you can have a good work ethic without being forced to have a good work ethic.
mm.
Um, I personally kind of wish I would have just been more confident in myself when I was younger and not, I don't know, like I kind of came from like a rougher area where it's kind of cool to like ditch school and like
Yeah, yeah.
do bad things and stuff like that. And you realize when you get older, like that's stupid.
Dumb.
Like do well in school and like be good at math and science and like the whole thing that like, math is, certain people are good at math or some people aren't. Like that's all a lie. Anybody can be good at that stuff. You just need to put the time in and like it does take time and work. So just like if it's something that if you're passionate about STEM or rockets or, whatever, um, just go for it and work hard at it because things do take a lot of work and it's not going to be easy, but that's kind of what it takes, especially now. It's pretty competitive industry. So you like you kind of need to, I don't know, build yourself up and be better than your peers and
Yeah,
get to
man.
work.
Yeah, man, for sure. I totally get it, and I totally agree with everything you just said. It a little bit of let's say talent goes, it does help, but at the end of the
Yeah.
day, it's like it's all they're all skills that you can learn and they take
Yep.
work. So yeah, that's good to hear. Well, thanks for chatting with me, man. It was really interesting hearing some of your background just with the Air Force and getting into school and now working at Sierra Space and everything. Like it was really interesting. I'm glad I was able to talk to you about it. So
Yeah, man. Thanks for having me and setting this up. It's fun.
Yeah, no problem. We should catch up again sometime.
Yeah, for sure.
All right, man. I'll talk to you later. Have a good one.
All right, you too. See you.
Thanks for listening to this conversation. I hope you guys enjoyed it, and I'll see you in the next one.